Okay, so this video is a supplement so that you can actually hear the last page of the 2.1 notes over writing and graphing inequalities, but really a focus on using set builder notation and interval notation. These are the new topics that I was explaining at the end of the last video before I lost audio. So now that you understand that this is just a different notation or way of writing a set of numbers, let's practice both the set builder notation and the interval and see what that looks like compared to inequalities and the graphs that we've been doing. So let's take a look at number 17. 17 is describing the solution set where all the x's are less than or equal to -2. So let's start with set builder. As I said before, set builder is really just kind of a fancy way of saying exactly the same thing, right? We just kind of embellish it with some more details. So we're going to say the set of, and that's what that curvy bracket stands for, all x values. And a lot of times we include what number subset they're in. Are they real numbers? Are they integers? Are they whole numbers? This is just real numbers. There's no other limitation here. So we're going to say the set of all x values in the real number set such that they meet the following criteria, that those x's are less than or equal to -2. And so that's the set of, or what we call the solution set. So this is, you see the inequality is actually still embedded in there, and it looks just like the original inequality. You just have this added frou-frou stuff and extra details all around it. So the set of all x values in the real number set such that x's are less than or equal to -2. Okay, now in interval notation, we want to think about the endpoints of that set of numbers, right? So if it's x's that are all less than or equal to -2, then on the negative or on the smaller side, the endpoint is just -infinity because it kind of doesn't have an endpoint. So if it's a one-sided inequality that when you graph it, it would have an arrow, then it's either going to be going toward the left toward -infinity, so technically we use that as the endpoint, or it's going toward the right toward +infinity. Okay, so if it's -infinity because it's a less than, then it never includes that value because there is no such thing as a value of infinity. So it is just going toward that, but it never actually includes that value. So we leave it as this, the parentheses, which means, you know, that's your endpoint, but not including that. It's in like an open circle, if you will. Okay, so it's everything from -infinity all the way up to, and then we think about what's the other boundary on this set, and it is -2. Does it include -2? Yes, it does. So that's the more square-looking bracket on the right side. So you're thinking in terms of endpoints here. You're saying, hey, it's everything in between these two edges or endpoints. And when it's a one-sided inequality, like all of these are, then it's going to be infinity, either negative, which would always be stated on the left. You always go from low to high, from small to large. So if it's going toward -infinity with that less than sign, then it should be on the left. And then in a moment, you'll see what it looks like if it's on the right. Okay? And then the -2 is kind of the upmost boundary, the highest number it goes up to. And we squared that off because it's or equal to. All right, next one here, number 18, it says that p is greater than 5. So again, set builder says the set of all p values in the real number set such that p is greater than 5. So just a fancy way of saying the same thing, that we're saying, hey, p is all is in the real number set, and it's just limited to values greater than 5. As far as interval notation, this time it's a greater than, so that arrow would be going to the right. That means that 5 is the left boundary. It starts at 5 and goes towards +infinity to the right side. So you always go, again, from low to high or from small to large. Okay, and because it's all the p's greater than 5, 5 is not included in that. And because it's infinity, that's never included. So it would look like that. That's interval notation. Okay, look at number 19. Number 19 says all the y values less than -6. So again, set builder says all the y values in the real number set such that those y's are all less than -6. And then for interval notation, less than means it would go on forever toward the left, toward -infinity. So when I think about the kind of the boundaries or endpoints here, it would go from negative infinity all the way up to, and negative 6 would be the highest value. It will never include infinity, and in this one, it also does not include that negative 6. It would be like an open circle, okay? So open circle on that negative 6 is not included, so we leave it as a parentheses. Number 20, t is greater than or equal to 12, so set builder says the the set of all t values in the real number set such that t is greater than or equal to 12. So there's one option, okay? That's your interval notation. I'm sorry, that's your set builder notation. And then for interval, it's t is greater than or equal to, so that would point toward the right. It's going toward positive infinity. That means that 12 is the lower boundary, and it goes all the way up to positive infinity, keeps going and going toward the right. That's why on the graph we would have a right-sided arrow. And it does include 12 because it's or equal to, so that's got to be that squared off bracket, but the infinity side will always be a parentheses. Okay, so that would show all the values starting and including 12 going on toward positive infinity forever. That's what that says. Okay, let's try it at the last couple of examples from a graph. So I'm going to move this up here. It lets me. There it goes. Trying to get it out of the way. Okay, and then from the graph, I feel like it's almost easier to see, especially the interval notation. But let's try 21. Let's start with set builder. This is the set of, you could pretty much pick any variable, but I'm going to stick with x. The set of all x values in the real number set such that those x's are, and based on the way that this is graphed, I would say greater than or equal to 1, right? It includes the 1 because it's a closed circle and it's shading toward the right, toward the positive side where the numbers are getting larger, so greater than or equal to negative 1. And then as far as the interval notation, we're looking at starting at 1 and going toward positive infinity. I can see that really easily from the graph. 1 is included, infinity is never included. Okay, and last one on number 22, we're looking at all of the values, the set of all x's in the real number set such that x is less than negative 2. I can see here that it does not include 2. And that it's going toward the left, and all the numbers that are smaller than that negative 2 shading toward that negative side to the left. And then for the interval, that arrow is going to the left. It's a little easier to see here that we're going from negative infinity all the way up to that negative 2. So now you can see why we put it in that order, because negative infinity would be on the left side, negative 2 would be that highest boundary. We never include infinity, and in this case the 2 is also not included because it's an open circle. Okay, so now you have a good example there of how to use both set builder notation and interval notation to describe a set of numbers.